Hi. Hi. Thanks for coming. How many of you have been to an ACS meeting before? How many have not been to an ACS meeting before? Wow. Did those of you that have not been to one, did you hear about it through the WhatsApp group?
Who's here from the WhatsApp group?
Thank you. Thank you very much. Welcome to ACS. American Cetacean Society, the Puget Sound Chapter. We are the oldest whale dolphin conservation organization in the world, founded in 1967. And this chapter, originally 1977, had a couple decade run, and then it fizzled for a bit, and then started again in 1999. We've been going pretty strong ever since then. Really strong tonight. It's nice to see everybody here interested in gray whales. Or maybe you're just interested in seeing John. I'm not quite sure. I am, but that's okay. So a little thing, stuff that our chapter's been doing recently. We helped to sponsor a thing called the Orca Cantata last weekend, and that was a lot of fun. Did anybody go to that? Oh, cool. Awesome. I know you were there. We have our chapter meetings the first Tuesday of every month, and except for the summertime, so from July through September we do not. And this is our second to last one of this season. I was talking to John a couple months ago maybe about nonprofit organizations and the difficulty that we're all having right now raising funds. And I just want to thank all of you who donated to us when you registered. That was really touching to me because we got more donations this time than we ever have, and I really, really appreciate that. So I was talking to John, and I was thinking, we haven't had a gray whale talk in a long time, and the thing that really spurred me on to starting this chapter back in 1999 was gray whales, and it was the whale hunt that had been going on. And I talked to John, and he just said, hey, how would you like if I talked about gray whales? And I thought, well, that's perfect. And that was a couple months ago, and now gray whales are really in the news and not good news. And I assume that's probably why a lot of you are here. So appreciate you coming for that. No problem. There's a couple of seats over in the back.
Thank you.
So I'm kind of rambling on a little bit about what's going to happen and what has happened. And just wanted to say that our chapter, we've taken an ecosystem approach to achieving the mission of the Cetacean Society, and that is to protect whales, dolphins, and porpoises and their habitats through research, education, and conservation actions. And some of the things that we do, we've got our little whale-friendly yard signs up here to help to encourage people not to put any toxins in their yard or in their home, and advertise it to your neighbors so they know that, well, maybe this is something I should think about. Still trying to get my mom to do it, and for years she blamed my dad, and now my dad's in a home, and so she can't blame him anymore. Still is like toxins on to kill the moss, which I'd rather kill the grass. But so it's a good thing to kind of start thinking about the little things that we do that make a difference. And I just want to mention one example of something that just happened to me. Just today I got an email from PCC, the co-op around here. You probably know what PCC is. I was there a couple months ago at the Green Lake Aurora store, and there were these little yellow signs, little flags, and then there's another sign saying that chemical treatment has been put on this. There's a little patch of nature in the parking lot. And that was kind of strange to me. So I wrote a letter to them and said, what's that all about? And they said, oh, well, it's this chemical, I forgot the name right now. And we just use it it doesn't harm any of the animals. And I thought, well, that sounds very suspect. You're supposed to be an organic or certified organic store. And so I wrote back about that and said, you're supposed to be certified organic. And this chemical actually does harm aquatic life. And then mentioned how marine mammals are 10 times more susceptible to toxins than terrestrial mammals are. And they wrote back and said, well, we're 100% organic in the store, but not necessarily around. But after I wrote all that information, I got another email back today saying, thank you for your letter. We have now talked with our groundskeeper company. They will only use mechanical means and hand pull weeds and use no more chemicals at all. So that's a really good example. That gave me a little hope, because I've written to them about a lot of things over the last few decades, and they haven't done anything. So of all corporations, they're maybe the most susceptible to doing something right, but we can all make a difference. So whatever it is that you're passionate about, just do it. Follow that passion. So now let's take you to the reason you're here, is to hear John talk about gray whales. And I've known John for I can't remember how long. You've probably all read his bio when you signed up for the event, and so I'm not going to try to memorize it or repeat it, except that he did mention in there some of his awards, and one is from the American Cetacean Society for a Lifetime Achievement Award in Marine Mammal Science. That was in 2012. And I'd say it was a little premature, because John's done an awful lot since then. So maybe it's time for a second lifetime award.
I think I didn't take the hint.
Right, maybe. But something you don't know about is that John makes incredible spaghetti sauce. And that's something that kind of kept us alive some of the times I've been out in the field with him. So I'm going to let John take the rest of this.
Thanks. The one downside, we were talking about it at dinner, of giving an ACS talk in Seattle, is that it seems to have negative consequences on fin whales. Because when I gave a talk when the national meeting was held here in Seattle, 2002 maybe, it was a year that we had 4 fin whales wash up dead in Washington State that year. So I will be talking, we did have a fin whale strand alive last night up in Samish Bay, just north of Samish Island. And it did die mid-morning this morning, and there was an exam, and I'll have some slides just at the end about that. But it'll mostly be on gray whales, but a tiny bit just about that, just because that just occurred. And so I have some of the information from that necropsy. Gray whales, you know, I've fallen in love with gray whales. There's sort of a trajectory that I think I maybe didn't appreciate gray whales for a long time. They were viewed as one of the success stories in coming back from whaling from a low of just a few thousand animals in the early 1900s, coming back to what we thought, and maybe, you know, it was their historical carrying capacity of, you know, well over 20,000 animals by the 1980s and 90s. That was a really successful, you know, comeback. Also, we kind of viewed them as specialized feeders, maybe a little bit primitive looking. They kind of, if you see a rock that's moving in the water, there's a good chance it might be a gray whale, because that's kind of what they look like. They don't have a dorsal fin, and they have this often barnacle encrusted, multicolored back that can fool you that way. You know, they're not supposed to be, weren't thought to be like other baleen whales, particularly social. And this was before we realized all of those things were wrong. You know, sure, they are specialized feeders and able to take advantage and feed on organisms on the bottom more effectively than any other whale, but they've actually had more different prey types identified that they feed on than any other baleen whale. And they're able to feed in the water column, on the surface, in kelp beds, as well as on the bottom. And some of the sounder gray whales that I'll be talking about tonight proved to be extremely social with each other in really interesting ways that we've come to appreciate. And the more I've studied them, the more I've sort of realized, you know, we had really, in some ways, mischaracterized them. And I had mischaracterized them. And that's maybe why it was all the more painful in recent years that we've seen these really troubling new developments with gray whales that have occurred. And so I hope to tell the story both tonight of what's going on with the larger gray whale population and reason why it's alarming, but also talk about how some of our local gray whales actually represent a real sign of hope and ways in which gray whales are proving to be adaptive and trying to find ways to deal with this crisis or change. I know a number of you were looking, and Yuko was going through the baleen, and this is kind of my shot of the baleen, outside baleen plates looking at the outside of the mouth of a gray whale, or the amphipod view of gray whale baleen. This is looking through the lower jaw at the inside of the baleen, which, like you can see in the example that's on the table, these plates kind of turn into these frill-like hairs on the inside that is this really effective sieve. And so gray whales are part of this group of whales that are baleen whales that filter feed. Now, in Washington State, sometimes I group these different ways, but I sort of think about the gray whales in Washington State in at least 4 groups, and we could talk about subdivisions. The one we're going to talk a bunch about is what I call the overall Eastern North Pacific population, and I'll show you this is the main bulk of the gray whales that migrate from breeding lagoons in Mexico up to their primary feeding areas in the Arctic. We have the Sounders gray whales, a small group of these Eastern North Pacific gray whales that the same animals come back and have for, in some cases, over 35 years into northern Puget Sound to feed. We have the Pacific Coast Feeding Group, and I'll be showing this in a couple of different ways. That's a local group of several hundred gray whales that spend the spring, summer, and fall in the Pacific Northwest feeding. These sounders end up migrating on north to the Arctic. These Pacific Coast Feeding Group whales, though most of them don't come into Puget Sound, they're mostly feeding from Northern California up through British Columbia. They spend that spring, summer, fall feeding, and then they generally do migrate down to the Mexico breeding lagoons. And finally, I put over to the right the Western gray whales that I'll talk about at the end. And this was a group of gray whales that was thought to be entirely separate, generally fed off of Sakhalin Island and Kamchatka in the Sea of Okhotsk area of Russia. It was kind of recognized as a separate population that likely migrated down to its separate breeding grounds off China in the Western North Pacific. But that all sort of came into question when, I want to say, about 15 years ago, some satellite tags were deployed on those Western gray whales. And the first one that was deployed made a beeline across the North Pacific and hit the coast here in Washington and then went south to the breeding lagoons of the Eastern North Pacific gray whale population. And subsequent gray whales that were satellite tagged in that area did something similar. And then we started matching our catalog and the Mexico catalog to the Western North Pacific catalog. And I think now we're up to 30, 40, or 50 known matches of individuals out of the few hundred Western gray whales that have been matched to the Eastern North Pacific. So what does that mean? Well, we don't really know. Was there a Western North Pacific gray whale population that migrated down to China and maybe was wiped out completely and then got recolonized by Eastern North Pacific gray whales whose population was much larger? Is there a mixture of those whales? Because there have been whales that have been reported off Korea and Japan that maybe seem like there is still a remnant population of Western gray whales. But anyway, we got Western gray whales off Washington. So I've got to make it one of the 4 groups. And I probably just told you everything I want to talk about for Western gray whales, but I do have a few slides about that. But just to look at it spatially, North Pacific, here's our Western gray whales. Sakhalin Island is about here, just off the map. This is the migration route of the overall population from breeding areas off Baja up into their primary feeding areas in the Arctic. This area in green encompasses the range of that Pacific Coast feeding group that doesn't migrate north, but does go down to the breeding lagoons. And then here, if we zoom into Washington State and into this little shaded area is our temporary stopping area of the Sounder gray whales. So just to look at that spatially. So starting with the eastern North Pacific gray whale population, and I took this slide off of NOAA's page, and I'm going to show you a couple of things that come from the NOAA, that's National Oceanic and Atmospheric Administration, that does regular censuses of gray whales migrating of this larger population. And again, that shows that main migratory route of that overall population. And this is a really helpful graphic that Southwest Fisheries Science Center put together that shows you the very troubling trend. So they estimate that gray whale population from these counts of migrating gray whales going southbound off California. And they come up with an estimate, and the scale on the right, you'll see the estimate kind of came back to that over 20,000 by the 1990s. And then these shaded areas show a couple of these periods where declared unusual mortality events occurred. And you can see that the population estimate dropped during those mortality events. And what it tells you is these mortality events that were documented by strandings and documented in each case hundreds of gray whales washing up dead, much like what we're seeing here in Washington, actually reflected thousands of gray whales dying because the population estimate dropped by many thousands. And the most troubling trend is what we have here. From 2016, 2017, an estimate of 27,000 gray whales to the most recent estimate of 13,000 gray whales, so less than half in 10 years. That's a major decline and a precipitous decline. Initially, and I'll show you a longer term series that will, I'll explain why I think there was actually even an earlier mortality event that affected the population. But after both that one and this one, we tended to see a rebound of gray whales. And so in the early years of the most recent set of mortalities that started in 2019, I was concerned but not alarmed because, okay, we know these mortality events, we know they occur with gray whales, we know they last a couple of years, and then the gray whales seem to come back. Well, that's not what's happened this time. And even though the unusual mortality event was declared over in 2023, we thought we saw a drop-off in mortality, and you can even see the population estimate rebounded. Now it's actually continued. We're really, I would say, in at least the 7th year of above normal mortalities of gray whales occurring. On this lower figure are these calf counts, and these are done on the northbound migration by Southwest Fisheries Science Center. And they've been doing these for something like, I forget, 40, 50 years. And generally they document, 1,000 or up to even 1,500 gray whales born each year. Well, 2025, the most recent year, 85 calves documented born, the lowest in their entire monitoring period. So, really troubling signs of what's happening to the population, both in terms of strandings, their population estimates, and in terms of calf production. Now, we have several lines of evidence, and the sounders and the PCFG and the western gray whales are part of this story, and I'll just preview that of why do we think this is happening to the eastern North Pacific gray whale. These big mortality events that affected this larger group that migrates up to the Arctic, we're not seeing those kind of mortalities in the other gray whale groups we study. Even the sounder gray whales that are part of this group, but have found this alternate area to feed, are not showing huge die-offs like what we're seeing here. So that's what's really pointing the finger at something related to the Arctic feeding grounds. That's what's unique about this group. And then the examination of these animals show they're really emaciated, really thin. That was a little bit tricky because normally gray whales go through a winter fast during their migration and time in Mexico. So this time of year, spring, is when they're thinnest normally. But what we were seeing were whales that were extremely thin. And even when you'd sample their blubber, you think of blubber, okay, that's fat, right? But their blubber layer would have no oil left in it. Less than 5% lipids in some of the tissues we were examining. So that really shows, again, these whales that are dying, it's because they didn't get enough to feed last year. And it's not enough for them to make it through this period of fasting. And this is where they would be headed back to resume feeding, but they don't have enough to make it. The mortalities in these unusual mortality events, and this just taking the 5 years of the declared mortality event from 2019 to 23. So I took this from NOAA. All of these pins show where dead gray whales were found, from the breeding lagoons and from Baja all the way up through the entire migration pathway. So the mortalities were occurring all along the range. The mortalities were primarily occurring, in winter and spring. So again, matching that fast, surviving through that fast period. And you can see here the mortalities, overall, and I'm going to show you in much more detail our Washington State data in a second. But you can see here's that big spike in mortalities in 2019. You can see how it appeared to be decreasing, and you can kind of see why NOAA, and some of us that sit on NOAA's Unusual Mortality Event Advisory Committee thought, okay, looks like this is winding up. But then it's come back up. Okay, I think in Washington State, we probably have the most detailed long-term record of gray whale strandings. Part of it has to do with the fact that, and I've been involved in this going back to the 1970s, but the National Marine Mammal Laboratory was here in Seattle and Washington State. We've had a number of participants in the kind of Northwest Stranding Network, groups like the Marine Animal Resource Center, MARC, that was based here in Seattle. We had pretty good responses to gray whale strandings in Washington State going back to the 1970s. And so this is, number of gray whale strandings in Washington State. And this scale, if you can't see it, is 5, 10, 15, 20. And these are years going from 1977 to 2025. And what you'll see is, on average, it's really on average about 5 strandings a year, long term. But then you'll pick out the high periods. Here's our recent period we've been talking about, 2019, started off with a bang, 35 strandings in 2019, our record for any year. You'll see 1999, 2000, that was that other unusual mortality event. Here is that 2-year period. And if you go next down, though it might not jump out at you, here's 1990, 91. That's the next highest 2-year period. So if you can remember 1990, 91, 1999, 2000, and 2019, those are our periods when mortality increased. Because I'm going to come back to that. But first, let's talk about this year. This year, we were up to 17 strandings so far. So we had 18 last year, so we're not quite there yet. But the majority of our strandings generally occur in May, is our biggest month, and June, and to some degree April. So to be at 17 by the end of April, that is really unusual. And I wasn't sure exactly how unusual it was. These are mostly adult animals. They've been mostly adult males. You can see the locations. Quite a few of them are outer coast, but some of them have been into the Salish Sea, up off Anacortes, and near Squim and near Deception Pass have been some of the ones closest to us here. We also have quite a number of gray whales swimming around that look in pretty bad condition that I think might be headed for this list. So the reason why this troubled us so much and the pace it was coming at is now, here's that graph I showed you a second ago, but now I'm only showing number of strandings through the end of April. And now you'll see that though in those unusual mortality event years, we sometimes had 10, or in 2019, we actually got to 11. Here we are at 17 this year. So 50% higher than any other year we've ever seen in terms of strandings to this date, this year. So that's even worse. Now, there's a reason why that's even worse than that. And that's because in 2019 and right before 2019, we estimated the gray whale population at over 25,000. Now it's down to 13,000, less than half, and we have more stranding. So as a proportion of the population, that's even more significant. So that's why I've gone from concerned to really alarmed about what's going on for gray whales. When you look at where these strandings occur, this goes through 2025, and you can see the strandings in Washington State occur kind of throughout the area. I did this graph just showing by half degree of latitude how many strandings there were. And you can see we do tend to get a little bit, the highest number around the Grays Harbor area, and then it tends to decrease as you go north. Some of that may be due to like current and how the beaches slope, but we also think there probably are some strandings going undetected in that remote part of the northern coast. Okay, why, again, I'll just do a little reminder. Here's our 3 time periods, 1990, 91, 99, 2000, 2019. Here's a little bit longer time series of the gray whale population estimates. And again, these big declines documented occur exactly matching up with those population estimates. And then I'm going to I'll save the last part of the connection. So what's, for a while, I think we got it a little bit wrong. So Josh Stewart, a really great researcher, modeler at Oregon State University, published a paper in Science that I worked with him on that tried to take all of these inputs from the calf numbers, the population estimates, body condition measurements, the stranding numbers, all of these things, and even some data from the Arctic, and put it into a model. And that's what this publication was, to describe this model, because these abundance estimates have some error associated with them. So it pulled in all these data sources and sort of confirmed those decline periods. But what we maybe got a little bit wrong in this paper is that we talked about boom-bust cycles. You can see that title right there, that maybe this was a little bit of a normal pattern for gray whales, that, they have these, up and down swings. Maybe we hadn't seen it before because their population had been depressed and well below carrying capacity. But now that it had come back to carrying capacity, it was more now reacting to any changes in the food supply in the Arctic. Well, now that that mortality event went on, the boom-bust cycle is looking more like bust-bust cycle. And so we actually did publish recently another paper trying to get it right, pointing out, oh, look, and you can see we extended those time series and tried to bring in and say, okay, it's not bouncing back this time, and trying to point to some of the changes that appear to be occurring, and we described that as sort of changes in the carrying capacity. Something seems to be affecting the carrying capacity of gray whales, and that is clearly thought to be something related to their prey in the Arctic. Now, there's not a ton of work done on this, but Jackie Grebmeyer and another researcher that's worked with her, Sue Moore, based here at the University of Washington. She's out of town. I invited her because I would have loved to have her maybe show these slides and explain them. Have looked at some of the prey abundances in the Arctic and the primary feeding grounds where gray whales feed. And there have been these dramatic changes in the Arctic ecosystem, over recent decades, changes in the ice cover. But I think what has really affected things is those changes also reflect changes in current patterns, how sediment is being deposed, the water temperature along the bottom. All of these things are being affected by that. Particularly down in the northern Bering Sea, down here in an area called the Chirikov Basin. That was a main area gray whales fed, and that represented kind of where gray whales could access historically, some of their prey as the ice conditions freed up. And that was an area with really high prey abundance. Now, in this figure here, these are plots, and I kind of pasted together some of the plots out of Sue Moore's paper here, hopefully into a somewhat cogent. If we can focus for a second on this lower, that matches this lowest box here. And these are prey densities here shown. Blue is low, these yellow-green are high densities of prey going to red. And this is time going from 2010 up to 2020 and up to 2019. And you'll see, like in this main area that gray whales used to feed, the prey has kind of disappeared for gray whales. It's dropped dramatically. And you see a similar pattern here in this next area to the north with a drop. Now, what's confusing is the fact the gray whales have also now expanded. They've moved into these areas they couldn't access before. And some of those areas do have prey, and that's what some of this describes as well up here. So it's not an easy conclusion to just say, oh, their prey dropped and the gray whales are there and they can't find enough to feed. They've actually expanded into new areas in search for them, and that's what's made, this more complicated picture, and why I try to say it's not just a simple relationship. Oh, less ice, less prey. Yes, Joe.
So what are the prey, and are they the
Yes.
same in the 4 different regions?
Yes. And here you're going to test, what it says in the literature, because I'm mostly familiar with what gray whales feed around here, ghost shrimp or swarms of mysid shrimp. But up here, these are referred to these ampellicid amphipods, benthic amphipods, so small creatures that live in the bottom sediment. And gray whales use that unique feeding, which we're going to look at some video and some images of, where they kind of basically turn on their side and suck in this sediment into their mouth, and then filter out anything that's in the sediment, through this, feeding mechanism that can be really effective if there's lots of prey, but can be incredibly ineffective if it isn't. You're expending all this energy, and if you're not getting much in doing that. One of the reasons why I was always trying to wrap my head around how the changes in ice condition changed conditions for gray whales is that if you go back, and this is my problem, I go back a little ways, a researcher named Wayne Perryman at Southwest Fisheries Science Center used to study the relationship between gray whale calf numbers seen on that southbound migration and what was happening with ice in the Arctic. And he found a positive relationship that the less ice there was, the more calves were born the next year. So it looked like gray whales were benefiting from less ice. And his explanation for that was, well, when there's less ice, because there's, part of the challenge with looking at things like climate change is you have normal annual variation, you have patterns that, go 3 to 5 years or even decadal oscillations that occur. And really what we're interested in climate change is what's this trajectory over much longer periods of time. And I think, to me, the way I've envisioned it is, okay, less ice in the Arctic, short-term benefit to gray whales because now they can get to more areas. But if ultimately that results in less productivity and less ability of their prey, to form these dense beds that gray whales feed on, long-term consequences to gray whales. Okay. This is just to show, some of the changes that have occurred over time, how these changes in ice cover ended up affecting, in particular, temperatures right along the bottom, which certainly probably affected some of these organisms that go on, and I won't go into detail on that. This is just another researcher looking at some of these broader changes affected by these, loss of ice and climate change related changes in the Arctic. The Arctic is known as one of the areas that has been most affected by these long-term changes in ocean conditions and climate. Okay, so now we're going to switch a little bit into the sounders and a little bit more uplifting story about them. And this goes back to 1990 and 91. And this little photo on the left may not be clear to you. This is an aerial photograph of a mudflat at the Snohomish River Delta off Everett. And this is one of the first ways I got contacted. There was a graduate student at the University of Washington named Lori Whitecamp who was doing her master's thesis on ghost shrimp. And ghost shrimp is a burrowing shrimp that is actually harvested and used as live bait in fisheries, and it's managed by Department of Natural Resources and Washington Department of Fish and Wildlife. And she was doing aerial surveys, of some of these ghost shrimp areas, and was seeing these little dimples that you see here. And I'll show you a blow up later. Each of these little dimples that you see here is a depression in the mud in this area that is exposed at low tide, but is covered by 7, 8, 9 feet of water at high tide. And each of these dimples is about 10 feet long and about 4 or 5 feet wide. And she was wondering, could these be made by gray whales? And at the same time, we were just starting our research and had discovered that we had gotten these reports in 1990 of gray whales up around Whidbey Island and Camino Island. And we got our first identification photographs of some of those whales. And in 1991, when she contacted me, we'd gone back out and we saw some of the same whales we saw the previous year. And they were using exactly these areas. So we were going, well, yeah, gray whales feed on the bottom. We've been documenting gray whales in that area at high tide, and kind of put that together, that these gray whales were coming into these areas at high tide and feeding. And this, here you see a little diagram. This is done by Hannah Clayton, a graduate student, a PhD student at Stanford that's working with us specifically on gray whale prey. These whales are kind of going in, turning on their sides and feeding on the bottom. If you're in a boat, it looks like this, where you have like part of a fluke and part of a peck fin above the water because they're just barely in 7 or 8 feet of water. And these whales are trying to feed in this extremely shallow water. And some of these whales extremely distinctive. Part of our great original naming system, we gave this whale the exciting creative name of Patch. You could identify Patch, and pretty soon even some of the residents of the area, oh yeah, we saw Patch. They could see that Patch from a long way off. Now, you look at how did these gray whales get here? Here's the main migration route of gray whales in the spring, northbound. Here's what a gray whale would have to do to come to the sounder feeding area. Have to make a right turn, come down the Strait of Juan de Fuca, find this little opening in Admiralty Inlet, come down through this narrow area, come around Whidbey Island, and here's the sounder feeding area. So we started to wonder, God, what would drive whales, to leave their migration path and explore these new areas? And not only that, but engage in this incredibly high risk feeding strategy. They're feeding in the intertidal area, an area that if you get the timing wrong, you're going to end up stranded. Here you see a table, and these are different individuals of what we call our sounder gray whales. Starting with the first 2 whales we identified in the first year. And these are years, 1990, and shading means we saw the whale that year. So think of it just as a diagram rather than, and you can see the first 2 whales in 1990, and you can see by 1991, we had identified 6 different whales in that area. We ended up naming those first 2 whales, one was a male and one was a female, Shackleton and Earhart. You might be able to guess why. Earhart we view as our pioneering female, and she really has been impressive, has been coming back. You'll see that there are clear areas, and that means we didn't see the whale that year. But keep in mind, especially in these early years, we were sometimes only doing a couple of surveys a year. It was before there was any whale watching activity, before people had caught on to these gray whales in this area. So we might have just missed them that day and not seen them. So I wouldn't put a lot into these gaps. But some get kind of interesting. If you look at Earhart, the second row, you'll see that whereas Shackleton is seen every year, now that we have more consistent effort, Earhart was not being seen about once every 3 to 5 years. And we never saw her with a calf. So we wondered, maybe those years we don't see her are the years she has a calf. And then through, one is a match to one of the breeding lagoons in Mexico, where she was seen with a calf. And then in 2 other years, we could detect she was pregnant from some of the photogrammetry that I'll show you some of the images of that could detect pregnant, and it confirmed that that indeed was why we would not see her in these occasional periods. Why does she not come with a calf? Well, mothers with calves tend to migrate later. So maybe because she's migrating later, it makes more sense to go ahead and migrate to the main feeding grounds. The sounder gray whales primarily are there from February to May. But I'm going to show you that's changed as well. But maybe if you're only migrating and it's already May or June, let's continue on to the Arctic, our main feeding ground. So that could be the case why, or it could be this would be an incredibly dangerous place to have a young calf. So maybe that's why it doesn't make sense to come here. Now, if you look at this figure, you might notice a couple of things. Here's 6 individuals, and they joined in 1990 and 91. Then you'll see here another group of 6 individual joins, and that's in 1999, 2000. And then you'll see here a bunch of other individuals join, and that's in 2018 and 2019. So if you remember the 3 time periods of higher mortality. So now to answer the question, what would drive whales to leave their migration path, try to discover new feeding grounds, and engage in this high-risk feeding strategy? Well, it's desperation. Those were years that the gray whales were facing that major mortality event. And that's what the sounders represent, whales that have found a way to adapt to this new challenge that they're facing. Yes? Yeah.
So what is the distribution of the ghost shrimp like? Because that's, it's such a specific area.
Yes.
Around Newbie and Camino. I mean, is that really kind of just where they are in Puget Sound and State of the Sea, or are they?
They do occur in other areas. Like, for example, we have real regular gray whales coming into Gray's Harbor that seem to be feeding on ghost shrimp. We do have the examples off Vancouver Island. There's some areas of ghost shrimp beds. So there are other areas they occur. But these areas in northern Puget Sound, that's the area that the commercial fishery for ghost shrimp works. I mean, I think these are really, really high density, rich areas, but ghost shrimp do occur in other areas as well. This just shows kind of number of sounders, how it's grown in recent years. This is another way to look at by decade, 1990s, starting in 1999 to 2018, and then this most recent period, how many sounders, gray whales, and what months they're here. And basically what you can see is, first of all, the trajectory of more and more sounders occurring. And then the other thing you'll notice, as I mentioned, they're here primarily February through May, that's this period, but you'll also see over time more and more evidence of sounders staying longer and arriving earlier. And that's become very dramatic. Like this year, 5 sounders arrived in December and have been here ever since. So they totally gave up on going to Mexico. So they gave up breeding, going to the breeding lagoons, instead came here to feed. Another sign of kind of what's the crisis they're in as it relates to feeding. Okay, and that's what all of that word says. Okay, you were commenting on the feeding areas for the sounders, and this is a little bit, subtle here, but you can see some of these areas in yellow, and these show some of the areas that the sounder gray whales feed, as documented on different dates where we did aerial surveys at low tide to document. And this is out of a master's student, Amanda Ruida at Evergreen, who did her master's documenting the area of these pits. Another insight, and I'm going to try to how am I doing? Try to pick up the pace a little bit here because okay, good. Another set of partners in our work have been Holly Fernbaugh and John Durbin, working with SR3. They kind of pioneered doing health assessment work with killer whales, but then going back a number of years, started working with us on the sounders and looking at how they gain body condition using these high precision drone overflights to look at body condition and how that changes through this spring period. And even they, and I certainly was, were shocked. This is the same whale in February and April of the same year. And the lighting looks a little different, but look how this animal goes from very skinny to very robust just in a few months. It's a demonstration of how successful this feeding area is for gray whales. So they have great success. And all of these upward curves you see here, this is by Julian Day and plotting different individuals. I won't go into detail. Most of these whales show this kind of a growth trajectory. But we do see, and this is in black here, some individuals, especially this, in this case, this was a new individual coming to this area for the first time. And it's an example of a whale that did not improve body condition. And that's why this is its line here, kind of stays flat. But mostly it shows the success rate of these whales in putting on and improving body condition. We've been trying to study some of their feeding habits using tag deployments and deploying these suction cup attached multi-sensor video cameras. And we actually deployed 41 of these tags going back to 2015 through 2024. And this is how we kind of used to deploy them right here. And this is using our small boat. This is my head cam from the driver's seat approaching a gray whale, in this case off Hat Island, just off the Snohomish River Delta. And we've got the tag on the end of a pole there, and this is Jen Tackaberry here with a biopsy dart. We actually are using a little kid's crossbow that will fire a dart and bounce off, but there we are putting the tag on, and she gets the sample, firing that dart that bounces off the whale. So that's how we used to do the tag deployments. Then we started to work with Ocean Alliance that's been pioneering doing these drone deployments of tags. So this is 2023, the first year and the first tag we deployed. This is the image from the drone, and there you see the tag and just dropping it on the whale instead. And kind of much lower impact way to approach whales and deploy these tags. The duration of the deployments tends to be a little bit shorter because you don't get that press on that you do like with the pole, but still we were getting much better data, and it actually helped us in a number of different ways in doing that. Especially in the tag analysis, we paired with the Stanford Goldbogen lab. Jeremy Goldbogen, the professor there, is worked with us as an undergraduate and then as a postdoc, and now as a professor at Stanford. We've had a whole series of graduate students working with us on different studies. And in particular, Hannah Clayton, I'll be referring to her work a bunch, is making her whole dissertation focused on the sounder gray whales. When we first deployed these tags, and I might, this is the video camera. We deployed this tag on Earhart in our first year, and I might just stop it for a second here. And this is two video images. They actually aim just adjacent to each other. And this right camera was perfectly aligned towards the head of the whale because we wanted to document feeding events. And these tags have all of these sensors, 12 different sensors on them. They're archival tags, meaning they can record tons of data, sometimes at hundreds of times a second, all stored on the tag. You just have to get the tag back. The tag floats, it has a VHF transmitter, so we have to get it back. And I'll later show you this and highlight a few of these sensor data. But for this, I just want to show you this perfect deployment. We are really excited about documenting feeding events. And this is within just a minute or two of our deployment. Here comes another whale. And bumps into Earhart and perfectly turns the tag backwards. So now we're facing straight back with this camera. Sort of disappointing, but it ended up being instructive. We wondered, how has this behavior and this knowledge of this feeding technique spread through the population? and you actually see one very clear way it spreads. This is Earhart. We tagged her when she was off Hat Island, and she is now headed into the shallows at high tide to begin feeding. And look who's behind her, since our camera's pointed backwards. But here we have one whale following her in. That's the whale that turned the camera around. And then as she swims and gets this timing of where to go and when to go, and this is the same whale, peckfin, that you see there. But then coming into view here, you're going to see a second whale and then a third whale over to the left. And this is 3 whales just following right behind her. There's our third whale there, right into the shallows. So you can see how this behavior could easily spread, and animals could kind of learn from each other, and why Earhart, even to a degree we hadn't appreciated initially, was a pioneer. Now, this, oh yes, no, we don't want to do that again. I'll just say that these tags usually only stay on for typically like 8 to 24 hours, not terribly long. But we ended up with some record deployments, 67 hours. One suction cup tag stayed on. And we weren't sure what was going on, but this is some video footage. Oh, let's go back. Okay, come on, John, let's get that. There we go. Here you see a tag, and you'll notice as this whale swims, you'll notice how the tag is really shaky and moving around. It's hanging on by only 1 of 4 suction cups. So it's kind of about to come off, and it's facing perfectly backwards. But look what happens here. Again, 2 whales following this whale and kind of rubbing up against it. And you can see the tag is really shaky. There's actually a brief view of a penis right there. So, there's a lot of these sounder whales are males. But then, so there's that contact there, and now you'll see a whale come up and kind of this whale right here, rub up against the whale, and right there, it turns the tag around, facing perfectly forwards now. Yay! But you'll notice no longer shaky. It pressed the tag back on. And that's why we got some of these record deployments on these guys. But all of the body contact you see was surprising. And these tags, the video only records for a few hours. And in fact, we ended up discovering some of the video seems to interfere with some of the sensors. So this video we primarily have from these early deployments. We actually started turning the video off because it was only a few hours of data and we were more interested in the data. But it did help us at the beginning because it helped us link some of that sensor data to what the whales were doing. So it was kind of useful at the beginning. I'll just show you what does feeding look like. And you don't always get the great view of it, but this is one view. But first, let me go down here to the sensor data. In red down here, this is a measure of the whale's roll behavior. And these plateaus right here go to this scale over here on the right. And each of these plateaus represent about a 90-degree roll to the right. So that's the whale rolling on its side and putting its right side against the bottom. And each of these represents a feeding event where it's actually creating and excavating a pit and sucking out the prey. And you'll see this sensor here is depth. And you'll see, and here's the scale here, and it's in meters. And you can see the depth the tag is at about 2 meters. So again, incredibly shallow. And so now let's look at what that looks like. Oh, maybe we won't look like what it looks like. Okay, I must have skipped that video. But you'll see the whale goes down to the bottom, and we'll just look at this image. These are all kind of siphon holes of ghost shrimp. And the whales would go down in these areas with all of these holes and would engage in this behavior. And we'll look at that from a couple of other routes. I will point out that gray whales do end up getting stranded alive. We've had a couple of gray whales in northern Puget Sound end up on the beach alive. This was a whale that actually stranded up in Claylock, where it was trying to feed with other Pacific Coast Feeding Group gray whales right in the surf, and it got caught up and pushed up on the beach and we actually were able to successfully rescue it. Okay, let's skip some things here. I'm just gonna, because I don't want to, let me transition for a second, and I'm gonna come back to a couple of things, but let me talk about the Pacific Coast Feeding Group for just a second. And we study the Pacific Coast Feeding Group with a number of collaborators up and down the coast, working from Southeast Alaska down through Northern California. And here's where I want to show you our abundance estimates of the Pacific Coast Feeding Group, that group that feeds in the Pacific Northwest from spring through fall. Its population has been, at least going back to the early 2000s, been remarkably consistent at about 200 to 250 animals. None of those huge fluctuations that you saw, and you certainly don't see a big precipitous decline at 2019, like what we're seeing with the Eastern North Pacific population. And then these show the number of calves born now to the scale on the right. And they do go through periods of elevated numbers of calves being born. But again, it is not in sync with that overall Eastern North Pacific population. These whales feed on different prey than either the ghost shrimp that the sounders feed on, or those small Ampelicida amphipods on the bottom up in the Bering Sea. These whales are subsisting more on swarms of mysid shrimp and other organisms, and they don't show the same kind of fluctuations. Okay. I will point out that part of the concern around the Pacific Coast Feeding Group has been around the macaw hunt. In the late 1990s, gray whales were delisted from the Endangered Species Act because their population had shown that remarkable recovery. The macaw proposed that they resume their traditional historical hunt of gray whales. And in fact, in May 1999, they did kill this whale, initially throwing a hand-powered harpoon, but then dispatching it with higher weapons. And that was a resumption of their hunt that had ended in the early 1900s. This photograph is actually one of the historical photographs from one of the last whales they had taken back in that earlier period. After this, the gray whale hunt was legally challenged, that it hadn't gone through the National Environmental Policy Act and an environmental impact statement, that there hadn't been a formal exemption to the Marine Mammal Protection Act. And so that suit ended up halting the hunt. And it's sort of been caught up in legal proceedings almost since, but I've understood that the decision by NOAA, both now granting the macaw this permission after these legal challenges, has been imminent for almost the last 6 months. So I would anticipate we might hear about this at any point and this hunt would resume. What I was concerned about when this hunt was first proposed, that Pacific Coast Feeding Group represented only a few hundred animals, and it used that area around the macaw area, and I worried about the impact the hunt could have on a small group like the 200 gray whales that are the Pacific Coast Feeding Group. Even though NOAA is one, an earlier slide I didn't go into, US and NOAA have been reluctant to recognize the Pacific Coast Feeding Group as a distinct group. They kind of do this wishy-washy in-between thing that I can answer a question on if we want to get into, but they've stopped short of recognizing it as a distinct group, even though the International Whaling Commission and Canada recognize the Pacific Coast Feeding Group as a distinct group. Both the macaw and NOAA have basically now developed a management plan that would try to minimize the impact on the Pacific Coast Feeding Group. The hunt would, in some years, only occur in spring, and they would monitor every whale taken to make sure it wasn't a member of the Pacific Coast Feeding Group. And then in the every other year, they would be allowed to hunt in summer with the Pacific Coast Feeding Group, but then they would only take like a single whale to make sure that they didn't have that impact on the Pacific Coast Feeding Group. Okay, these are just these slides I was going to show about Western gray whales. This is this very first whale. It was named Flex, that was tagged off Sakhalin Island, and I said, made this beeline across the Pacific and came right here to Washington before proceeding down the coast. And then it was several later deployments also showed these other whales tagged off Sakhalin Island ended up coming over and feeding on that. I did want to point out a couple of things, and I'm just now kind of wrapping up, that we really do need some key areas of research. And one is, despite some of the really good work by Jackie Grebmeyer, working with people like Sue Moore, on some of the benthic prey in the Arctic, this is still a huge area we need to understand better, to understand what's going on, how those changes in ice conditions have changed things for gray whales, and what is that likely to mean about the future? Is this going to continue in this direction or not? And that's what we need to then have a better understanding of that mechanism of the decline of those benthic species that gray whales depend on up there. The two things I'm working on a little bit is, can we come up with some alternate ways to estimate the gray whale population? The current population estimates are based on animals migrating south. But as I mentioned, with sounder gray whales, we had 5 gray whales that never made the southbound migration. So they would be missed by that census. If that's representative of what's occurring with gray whales overall, there's the possibility the decline isn't quite as severe as we think it is. What we need to determine that is to come up with an alternate way to estimate the abundance of gray whales. And for humpback, blue whales, other species, we typically use photo ID of individuals and mark recapture to estimate abundances. And I never wanted to do that with gray whales, because with 27,000 gray whales, that would be a huge endeavor to have a catalog that big. But now, with automated matching techniques that have been developed that are about over 90% effective with gray whales at finding matches, better automated ways to process and handle data. And then I hate to say this, it's a very negative way, and with a population that's quite a bit smaller, 13,000, I think we can now estimate with mark recapture that. So I'm looking at trying to develop a collaborative effort up and down the coast to identify whales and then use these mark recapture ways to estimate abundance. We've also seen evidence up and down the coast, and I kind of skipped over some slides of some of the really unusual things we're seeing in Washington. We're seeing really positive things with sounder gray whales, numbers increasing. Those are whales finding alternate feeding areas successfully. But you have lots of examples of areas gray whales are exploring, like San Francisco Bay, or lots more gray whales are going into San Francisco Bay, but they're mostly ending up dead. And some of what we're seeing in our area. So I think a really important thing to do is we need to investigate what are all the different areas, alternate areas, gray whales are trying to feed and adapt to this change in the Arctic. How many whales are using that, and in what areas are they being successful or not? And that's where we can use the lesson of our sounders, but now apply it to all these other areas to see, are there more examples of animals having great success, like the sounders, and what are the areas where they're not having success? Okay, getting down to almost last slides. What can we do? And I've been asked this question a lot in the last month. A number of these gray whales do die from entanglements and ship strikes. So we do know there's some direct causes of human mortality. We don't think that's the main thing that's changed, but we can look at ways to reduce that. I was part of a take reduction team recently trying to develop new ways to reduce entanglement mortality of whales. At Cascadia, we formed this partnership for West Coast Entanglement Action to be able to research and also go out and disentangle whales. So I think there are things we can do related to ship strikes and reducing entanglements. It's not getting at the main source of mortality. I think we need to, where we have examples of whales having successfully found new feeding areas, like the sounders represent, then we need to protect those areas. The sounders are exposed to high levels of vessel traffic. They compete for the ghost shrimp with a fishery. It's a small fishery. They face entanglement risk from a number of sources. So we actually have a proposal in to CDOC right now as part of their recent call, trying to look at what are the management protection actions we can take in some of these areas, like what the sounders use, to kind of allow more whales to succeed that way. These last ones really have to do with climate change. I think, and I especially feel guilty when I'm talking to like Canadian media outlets because the US has taken such a huge step backwards in the last year and a half over climate change issues. Going from that being a pressing issue in this country, a powerful youth movement, political action being galvanized, US taking a leadership role, in international conferences, to all of that being the opposite. I mean, it's gotten to ridiculous points. Like, for example, any proposal I put into NOAA to keep doing work cannot include the words climate change, or it is automatically rejected. It's one of the key words searched for by initially the DOGE team, to identify, just ridiculous things. You can't have anything, and even things get, like NOAA used to want to encourage, diversity and equity, and part of the sections in the Prescott proposals we would put in was a section about that. Well, now you can't have those words in there. They have to be removed out of the Prescott proposals, even to the state of you can't talk about diversity in the marine environment. You can't use that word because it's just a word search. Just kind of like ridiculous stuff like that. So that's playing. So we need to find a way to turn that around. Our politicians that represent us in this area, people like Cantwell and Murray have been leaders in trying to do this, but we need to find ways, to keep encouraging and supporting them and try to get us back to being leaders in that issue domestically and internationally. NOAA, which is the main agency that is in charge of marine mammal protection, it issues the permits, it manages all the marine sanctuaries, it's the enforcing agency, plays this huge role in marine mammal action, has lost 30 to 40% of their West Coast staff in the last year, mostly through voluntary and forced retirements. So that's been kind of huge. They are our primary supporters for research over the years. I think 70, 80% of our funding at Cascadia over the last 40 plus years has come from NOAA. Well, that's dried up. And what's interesting is, Congress put NOAA's budget at 2024 levels. But what NOAA is done, like we have one grant to continue study of the whales in Washington State. It was under this program with the states, partnered with the Washington Department of Fish and Wildlife. It was recommended and selected for funding. But when it went to DC, it had to be signed off by the Secretary of Commerce. And that's where it just sits and has sat there for over a year. So I worry that even congressional appropriations, even when they're there, within the executive branch, they can just go, oh, well, we don't have to actually spend it. You can appropriate what you want. So finding ways to force that, and obviously we need a stronger Congress, and maybe we're going to get something in the fall to head that. Okay, that's the end of my gray whale talk. I said I'd just show, this was the fin whale that stranded last night, and this is a photograph from this morning, shortly before it died. It was a 61-foot male. We have had like 13 previous fin whale strandings since '86, sometimes up to 4 in a year. And this whale, from the examination that was conducted this afternoon at low tide, it was not only emaciated, which you can sort of see from that photograph, and had a skin condition. It had some fresh killer whale scars on it, so it had been recently subjected to a killer whale attack, and it also had some fresh entanglement scars. So this whale has been through a number of things. The tissues were obviously very fresh, and they were able to sample tissues, so would have to wait a little bit to get the full story on what other surprises that might hold or how those different factors interplayed. We do not think this is, we get these occasional fin whale strandings. This is the only one in the last 2 years. And so we don't think this is anything related to the gray whale mortality. Okay. Cool. If you're into scanning QR codes, if you want to support our research, these are some ways to either get on our mailing list and newsletter, or if you want to donate, you can do that through those QR codes. I'll leave that up. But why don't we go lights on and I can take kind of questions. How are you doing? A little long. You guys are very
We've
patient.
got room for like 5 minutes of questions.
Okay.
So on this previous slide about the fin whale, it said it wasn't a good candidate for refloating. What is refloating and why wouldn't it be a good candidate?
Yes, right. And some of you may have seen the news. We had probably our most tragic case last October where the humpback whale that stranded alive in near Yachats, Oregon, went down. And that was a case where we tried to refloat unsuccessfully in that case. The clay lock gray whale I showed, that was a successful refloating. And that basically refers to where a whale is on the beach alive and we try to get it out into deeper water where it can be safe. And the things we look for, and after I saw the photograph I just showed you, I immediately thought this was not a good candidate for refloating. First of all, it was big, 61 feet long, so that's bigger than anything we've tried to refloat. It was on this area of mud flat that it would have to have been carried a long way. But really, the bottom line for me that really separated it from like the Yachats whale where we did attempt it is the animal clearly wasn't healthy. It was emaciated, it had a skin condition. The people that had observed it saw it actually has come straight in and beach itself. It wasn't like the Yachats whale was a whale that got entangled and then was unable to kind of free itself and got pushed in by the surf. So the fact that it appeared to have stranded voluntarily and was in really bad condition, that's the point at which I think all we're going to do is add to the stress of that animal trying to go to these measures. So it would have been a case that, would have been a candidate for euthanasia if it had not died of natural causes. Most of the whales that we've had that have stranded live, that have been in poor condition, have typically died within a day or two. It's one of the reasons why usually euthanasia isn't looked to put into effect for a day or two, because that can be stressful. But anyway, that's why we didn't think it was a good candidate for refloating. Yes?
I'm so sorry about this, but I'm still confused. These whales are beaching themselves. Why? I'm still
Yes.
I have not gotten an answer.
Yes.
I'm so sorry about
Yes, no. And when and maybe I should have clarified right at the start, the strandings that I talked about, all of those strandings of gray whales are whales that die and then wash up. So the fin whale that I'm talking about is, a different category. So these are whales that have largely, we think heavily due to their starving to death, died and then wash up. And from the comparison of how many strand,
How do they know that they died and they got washed ashore?
well, often we see them. They'll be seen coming in the surf. But also there's some real other telltale sound. Sometimes these whales are like they've been dead a week or more by the time they wash up. So they're heavily decomposed. And then you have other indications, like a whale when it's alive will tend to be with its blowhole up. But when a whale dies, the backbone and the weight means it usually floats upside down. So most of these whales wash up in that position that also is indicative, that they died and washed up.
I have a couple questions.
Sure.
I'm curious, is there any explanation for the rebounds after the Emmys? Or any guesses?
Why they rebounded like
Yeah.
in the past ones. Well, we thought, and to me, the explanation I always had in that period was here you have this recovering gray whale population coming up to carrying capacity, and now it's vulnerable to up and down variations in carrying capacity. And then as you get that mortality event, that's probably with a dip in the carrying capacity, and that's what causes that mortality event. And then as that fluctuates back up, they can rebound to fill that again. What had been the surprise with the UMEs you know, and even one of the papers, I think it was maybe Sue Moore's paper, you know, she called, you know, from the 1999-2000, gray whales hitting K hard. And that's sort of a technical term. K is what's used as an abbreviation for carrying capacity. And the surprise was that, you know, as whales reach carrying capacity, you know, I would have expected as a long-lived organism that what you would see is a decrease in the birth rate, a slight increase in mortality, maybe an increased age of first reproduction, and it would more plateau and stabilize. And the surprise, and part of why we wrote that paper about boom-bust cycles, is that they were going through these big up and down vacillations of thousands of animals. And we've actually seen that in a few other populations of other large whales. And, you know, and that paper, and another paper by Josh Stewart, was sort of aimed at saying, maybe we just had this wrong, that, you know, maybe these animals are more subject to greater vacillation, because most of the scientific study of large whales has been in the post-whaling era, when the populations were really depressed and way below carrying capacity. And we're only now seeing and getting a chance to study whales as they actually are, in some cases, returning to that historical carrying capacity. So that was our initial explanation, that we thought, okay, they're hitting carrying capacity and they're subject to that vacillation. But that doesn't fit what's happened the last 7 years, that is more showing, no, something much more serious is affecting their prey base and effectively lowering that carrying capacity to way below historical levels.
And then the two other ones I had, I was curious, just one. You know, I have to decide which one.
I'll stick around.
Yeah, you can always talk after you have to.
I'm curious, in one of the graphs, it broke down the strandings between US and Mexico, and it seemed like in a couple of the years it was almost like a 50-50 split. Were the whales that were stranding in Mexico, was that on their way down or on their way back up?
Well, that's basically when they're down on their breeding ground. And I don't know if you'd like to say anything about that. We have someone who actually studied the gray whales Cascadia breeding lagoons about those. I know a number of them are calves that strand, but anything else, any insight you want to share on the Mexico part of the stranding?
Yeah, so we're just asking if they're stranding on their way down or on their way back.
Right, yeah.
So at least I was there this last winter, so that's all the data I have personally. But what we saw is there's a few that stranded right out of the blue, kind of in the start of the season.
Okay.
And then as they kind of stayed there longer and used up all that fat storage that they saved on migration, then they started dying more often as they ended to reach the end of the season. And then on their way back up too, we saw a bunch that we looked like they're not going to make it up because they were just skin and bone out there, and then they're just stranding on their way back up trying to look for food.
And then I was also Stephanie, anything you would, we have a veterinarian who's participated in a lot of necropsies of gray whales. Anything I missed, Stephanie, that you'd want to add from your expertise?
No, I mean, we do find on necropsies, we do find, interesting parasites and things like that, but a lot of them are secondary too, because when an animal, whether it's a human or an animal, is when we're in the starvation mode, our immune systems are suppressed and we are more susceptible to other diseases and parasites. So we do see a lot of those quite interesting findings, but again, most of these are starting. It's not human nurseries.
I think we've had on that list that I showed you, the 17 we've had so far, quite a number of those showed signs of blunt force trauma. And this has also been the case down in San Francisco Bay. And we think that's partly as these whales are starving and coming into unusual areas. And also as they get into a debilitated status, they become more vulnerable to being struck by vessels or getting tangled up in other ways. So there are ways, some of these other causes or diseases, they become more vulnerable to a variety of these as they become debilitated due to that low nutritional status.
Would you ready to thank John one more time?
I'll stick around.
Yeah, we need to clear out of the room in 5 minutes. So-
I'll stick around 5 minutes.
But we can all meet outside and keep talking to
Okay.
Thank you.